Hi everybody, it's Miss Austin, and I'm going to be helping you with the Unit 4, Lesson 5 practice problems. You might be doing these in Desmos, you might be doing these in your book and then submitting through Canvas, or you might be inking on them online. They start on page 155 if we're in our book. So today we talked about finding missing sides of right triangles, and we also talked about this idea of Pythagorean triples. A triangle has side lengths with 8, 15, and 17. Verify this is a Pythagorean triple. So I'm going to go ahead and just sketch what this might look like. 8, 15, 17. A Pythagorean triple is 3 whole numbers that create this right triangle. How do we know if it's a Pythagorean triple? Remember, in a right triangle, a squared plus b squared equals c squared. So instead of having to find one, we're going to verify that this actually do the 2 legs squared add up to the hypotenuse squared. Well, let's check. Is 8 squared plus 15 squared equal to 17 squared? We're going to use our calculator and see. So I'm typing this into my calculator here. 8 squared plus 15 squared is 289. Now I'm going to try the other side. What's 17 squared? 289. Yes, it is a Pythagorean triple. This is a right triangle. Approximate the acute angles in this triangle. So I know these two have to add up to 90, right? Because there's 90 already taken up there. And now we've been talking about ratios. So let me just pick, this angle right here. And I'm going to do the opposite, which is 8, over the hypotenuse, which is 17. And I'm going to type that into my calculator, and I'm going to see what I get. What's 8 divided by 17? I get about 0.471. So now I'm going to go to my table, which there's the tables that I think just the slide before this in the Desmos, or there was a picture of it on one of your agendas, or if you were in class, I passed this out. So I'm looking for an opposite over hypotenuse of close to 0.47. So 0.47 is just a little bit before 0.5, so I would say around, 28 degrees. So if this guy's 28 degrees, what's left for the other one? Well, what's 90 minus 28? 62. Okay. All right. Kieran is flying a kite. He gets tired, so he stakes his kite to the ground. The kite is on a string that is 18 feet long and makes a 30-degree angle with the ground. How high is the kite? How high is this? So what do I got? That's my opposite. And then I have my hypotenuse. I don't know my opposite, right? So I say, I'm going to set up an equation. I don't know over, I do know the hypotenuse. Okay? Now, we're going to go to our table. We know for a 30-degree angle, we're going to go look in the chart for 30 degrees. 30 degrees, the opposite over the hypotenuse should be 0.500. Right? That's what I should be getting. Now I'm going to solve this. Remember, we solved a bunch of proportions in this class. The easiest way is to put a 1 under this and to cross multiply. X times 1 is 1x, or just x. And what's 18 times 0.5? Hopefully you already know that. Oops. I'll show you on the calculator. 9. The kite is 9 feet high. Triangle ABC has a right angle C. Select all measurements, which would mean it has a hypotenuse with a length of 10. So we're going to have to do this problem several times. I might end up using a piece of scratch paper and eraser. It says A is 20, okay, and BC is 2, and they want this to be 10. So I'm just going to go ahead and do this ratio and see if that's what it actually should be. According to my trig table, if I take the opposite, which is what I got, over this hypotenuse, which is what they want, 2 divided by 10, that's 0.2. That's what I should have in the chart for a 20-degree angle for opposite over hypotenuse? Let's go look. Opposite over hypotenuse, 0.342. I got 0.2 if this is 10. No, doesn't work. I'm going to have to erase all this. All right, back to the drawing board. Second choice, it says AC is 7, BC is 3. And they want this to be 10. This is a right triangle. If that is 10, this squared plus this squared equals this squared. Let's try it. I'm going to just do it on my calculator. 3 squared plus 7 squared is 58. Is that equal to what 10 squared is? No. That doesn't work. All right, third one. It says angle B is 50 and BC is 4. And they want this to be 10. They're wondering if that's true. If this was 10, what do I have? I have my adjacent and my hypotenuse. So 4 divided by 10 is 0.4. If that is truly 10, if I go look up 50 in my chart for an adjacent over hypotenuse, I should get 0.4. Let's go look. 50 degrees, adjacent over hypotenuse. Do I get a 0.4? No. I get a 0.6. Doesn't work. All right. Angle A is 30 and BC is 5. And they want this to be 10. Let's check. That would be opposite over hypotenuse, which is 0.5. So I'm going to go look in my chart. If this is right, a 30-degree angle should have an opposite over a hypotenuse of 0.5. Finally, one of them worked. Yes. Okay, and then the last one. AC is 8, BC is 6, and they want this to be 10. Is that going to work? If this is true, this squared plus this squared should equal that squared. Let's check. 6 squared plus 8 squared is 100. Is that what 10 squared is? Ding, ding, ding. That works. All right. Number 4. What is a reasonable approximation for angle B if the ratio of the adjacent divided by the hypotenuse is 0.45? I guess I don't really need a triangle. So if the adjacent divided by the hypotenuse is 0.45, they want me to figure out about how big is this angle B. I'm going to go look at my chart for the adjacent over the hypotenuse. I'm going to get as close as I can to 0.45, and I'm looking around here. Adjacent over hypotenuse of 0.45. Well, it's somewhere between 60 and 70. Starting at 60, it's 0.5, and then it gets a little bit lower and lower. So is it 27? No way. 30? No way. 60? No. A little bit past 60, does that make sense that it would get to 0.45? Yes. All right, last one. Estimate the values to complete the table. So remember, when you have a triangle, the other two angles, A and C, they add up to 90. For example, if this one was 70, this one would be 20. If this one was 60, this one would be 30. Those are called complementary. And the answers to these, right? If I'm looking at angle A and I take the adjacent and divide it by the hypotenuse, if I switch over to this angle, that adjacent side now becomes the opposite side. So this answer becomes this one, and this answer becomes this one. 0.95, 0.31. Now, to get this answer, you've got two ways to do it, right? You can either look, this one says, because both of these are being divided by the hypotenuse, you could just ignore that mathematically right now. You could just take the opposite, which is 0.31, and divide it by 0.95. and we get 0.326. The other way you can do it to get this one, these ones are easy, you just flip. This one, you either have to take the opposite, now that you got it, and divide it by the adjacent, or you can take 1 divided by the one that they gave you. Watch how that works. 1 divided by 3.1. See how you, it's a little bit different because it was rounded, but basically 0.32. Okay? Number 6. I think I said last one last time. Sorry, we're doing number 6 too. What is the length of side AB? So I'm trying to find this guy. Now, if I use this 30-degree angle, what is that? That's the opposite. And they gave me this one, which is the adjacent. So I'm just going to write this out a couple of ways. I have opposite over adjacent. Okay? I don't know the opposite side. I do know the adjacent side. And I know what the answer should be. I go to my chart for 30 degrees. The opposite over the adjacent should be 0.577. Oops, my camera froze. Hang on. Hang on, people. There we go. Sorry about that. My opposite over my adjacent for 30 degrees is 0.577. So I know I want this to be 0.577. So I throw a 1 under this. Now I'm going to go ahead and cross multiply. X times 1 is 1x, or just x. And what's 6 times 0.577? 3.462. All right, and I think there are 2 more problems, but we weren't going to assign those today. Yep, 7 and 8, you're off the hook. That's a wrap. I hope that helped, and I'll see you soon.